Welcome back. In part one, we talked about what cal.com is and why it's such a powerful tool for avoiding all the usual scheduling headaches. One example we mentioned was instead of sending endless emails back and forth, cal.com links directly to your calendar so clients or patients only see the times that you are available. If you haven't watched part one yet, I recommend checking that one out first. You can find the link in the description. Now for this video, we're going to get hands-on, and by the end of the video, you'll have your own automated scheduling system running right on your computer. Before we dive into cal.com, there are two tools we need to set up first. That is Docker Desktop and Git. Docker allows us to run cal.com in an isolated container, so we don't need to install things like Node.js, Postgres, or any other softwares manually. Git, on the other hand, is the version control tool we're going to use to download the cal.com repository. When you install Git on Windows, you also get Git Bash, which is a Linux-style terminal. Without further ado, let's go ahead and get Git installed. We first need to head over to this website, git-scm.com. Once we're in here, we select the downloads option. We then select the operating system we are using. Currently, I am on Windows. We then get a few options and we want to install the first option. And once that's installed, you should be able to find the Git Bash application. The next thing we want to do is get Docker Desktop installed. We would first need to head over to docker.com. We then hover over download Docker Desktop and we should see the download for Windows AMD 64 option. That installation should install both Docker as well as Docker Compose, which we would need for our setup. Once you have Docker Desktop installed, you should now be able to find the application just by searching Docker Desktop. And once we select that, and we can see Docker Desktop has installed fine as well. There are a few other checks we can do as well to ensure that Docker installed fine. That is checking the versions, so Docker -- version, as well as Docker compose -- version. If you are a Linux user, the setup is even easier. All you need to do is run this command, and then this command to start up Docker. With Docker and Git now installed, let's grab cal.com itself. The easiest way to run cal.com locally is to use their official Docker repository. I have added the link to find the repo in the description below. This repo already includes Docker Compose YAML file, which takes care of starting cal.com and Postgres for us. We'll also find a sample configuration file that we can customize. Before we can get started, we'll first need to clone this repository. To clone the repository, we'll need to launch Git Bash. Once we have that open, you can go to a folder location where you want to keep your project. In my example, I am on my desktop. We'll then need to copy and run the following commands. The first command we'll need is the git clone command to retrieve the full cal.com repository. You can also specify a folder name for it. Once you've run the command, we then need to change directory to the new file location we specified earlier. In my case, it's calcom-docker. Inside the folder, we'll need two main files. These are the docker compose.yaml file and the .env file. The docker compose file is what lets us spin everything up with a single command. And the .env file is where we'll want to put our secrets and custom settings like database credentials and Google API keys. The next thing we want to do is copy the .env.example file to create our own. To do that, we'll need to copy the following command and paste it over to our Git Bash terminal. And once we run that, this command would copy everything inside the original file and rename it to .env. We are now ready to start configuring the .env file. You can use any text editor, however, I'm using Visual Studio Code. If you have that installed, you can use the following command to launch the repository. That is code space dot. Once you have your text editor launched, you should find the .env file. This is the file where you can configure things like secrets, Postgres settings, or the Google API credentials. We'll go over what each of those settings mean and configure them. All right, let's go through these settings one at a time so they actually make sense. The first line is the license consent. Setting it to true just means we accept cal.com's open source license. Next, we set the main web app URL. Since I'm running locally, this is just the localhost 3000. If you were hosting this public, this would be your actual domain name. Then we have the authentication URL. It points to the same address but adds API-auth at the end. This is simply the path cal.com uses behind the scenes when people sign in. The next line is a secret key. Its job is to keep login safe and secure, so it should always be unique and impossible to guess. We'll be using this command a bit later on to generate a key. After that, we have an encryption key. This one protects sensitive data like calendar connections. Later on, we'll use the following command to generate a key. Next up are the Postgres database settings. This is where cal.com stores information like users, bookings, and availability. We can define the username, password, and database name here. We then have the Google API credentials section. This is where we'll paste the details we get later on from Google Cloud, things like the client ID, secret, and callback links. The next two are for Microsoft calendars like Office 365 or Outlook. We're not using them in this setup, so we can leave them blank. Then we have the Zoom credentials. If you want bookings to automatically generate Zoom links, this is where they'll go. Since we are using Google Meet, we'll keep them empty as well. This section is for email notifications. It controls who the emails look like they're coming from and which mail server to use. For a local demo, we don't need this, but in production, it's very useful for sending confirmations and reminders automatically. And finally, we have the environment setting. By setting it to production, we're telling cal.com to behave the same way it would in a live environment. Even though we're running locally, it's good to keep things consistent. Okay, now that we've looked through the .env file, we can start generating the authentication secret and the encryption key that we mentioned earlier. We'll first generate the authentication secret using OpenSSL. You can copy the command from the .env file on the comments and paste that onto your terminal. You then copy the random string and paste it into the .env file. Next, we'll do the same and generate the encryption key. The command can be found on the comment section. We'll just need to copy this, open git bash, and paste that there. Copy the hex value and then just paste it into your env file. The next file we want to look at is the docker compose.yaml file. We don't actually need to edit this one. It already knows how to launch both cal.com and the Postgres database and connect them together. We can also see that it is using the .env file that we configured earlier, and it's using the cal.com image. Since the defaults are already set up nicely for us, we can just leave it as it is. Before we can launch the app, we'll need to pull the images. We'll need to run the following command on our terminal. This downloads the cal.com and Postgres containers from Docker Hub onto your system. Depending on your internet speed, this step can take few minutes the very first time, so don't worry if it's not instant. Once the images have been pulled, we can then launch the cal.com application by running the following command. The /d just means to run it in the background so we don't have to keep the terminal open. Behind the scenes, Docker will start two containers, one for Postgres and one for cal.com, and link them together using the settings from our .env file. To confirm if everything has downloaded fine, we can run the following command, docker --ps. This shows all the containers that are currently running. If everything went well, you'll see one for cal.com app and one for Postgres. All of them should be marked as up. If you are using Docker Desktop, you should also be able to see the cal.com images and the container. Now we can head over to our browser and type in localhost port 3000. You should see the cal.com welcome screen load up and confirm that the instance is working as expected. From here, you can walk through the initial setup wizard and create your admin account, set your name, time zone, and availability. Once you've completed setting up your admin account, you should see this other page now. You just need to put in your username, your full name, and the time zone. Select next. In this section, we'll be connecting our calendar. The one we are looking for is Google Calendar. There are a few prerequisites that we need to first do to get Google Calendar connected, and I'll be showing you guys how to set that up in the next step. Now that we've got our local cal.com project ready, it's time to connect it to Google Calendar. This is the part that makes scheduling actually useful. Whenever someone books a time with you, the appointment gets added straight into your calendar automatically. To make this work, we'll set up a project inside Google Cloud, enable the Google Calendar API, and create credentials that cal.com can use. Don't worry, I'll walk you through step by step. First, if you don't already have a Google account, you'll need to create one now. This is the same login you'd use for your Gmail, YouTube, or Google Drive. Without a Google account, you won't be able to access Google Cloud or connect your calendar. Once you have logged in with your Google account, in the top menu, you should see Project Selector. Click on New Project. Give it a name like Calcom Local. Leave the organization as blank if you don't have one, and select Create. You would then need to select the project, so that would be Calcom Local, and it should specify that you are working in the correct project. This project is basically a workspace inside your Google Cloud where all your settings, API, and credentials will live. Keeping it separate is a good idea, so everything related to cal.com stays organized. The next thing we want to do is enable the Google Calendar API. In the left sidebar, go to APIs and Services, and then Library, and then you want to search for Google Calendar API. Select the Google Calendar API and enable it. This step is important. If the Calendar API isn't enabled, cal.com won't be able to read or create events in your Google Calendar. This gives our app the permission to talk to Google Calendar. Once we've enabled the Google Calendar API, we then want to go over to our consent screen, and then we want to select Get Started, choose an app name, Select a user support email and then select next. For the audience section, we want to select the external option and next. And finally, provide a contact information for the email address option. Once we put that in, we select next, agree to the terms and continue. Once we've done that, we want to select create. The next thing we want to do is add in the required scopes by heading over to data access option. We then select add or remove scopes. And we want to add in the following scopes. The first one is auth/calendar, which is the first option here. We also need this auth calendar.read-only. And finally, this last option, auth calendar.events. Once you've ticked those options, just select update. And those should be added into your sensitive scopes. Scopes are like permissions. For example, one scope might allow cal.com to see your free and busy times. Another lets it add new events, and another gives full access if it needs to update or delete them. Without these, the integration might not work properly. The next step is to add in test users. What we want to do is head over to the audience option. And when you scroll down, you should see test users, select add users. And what you want to do is add in your Gmail email account. This is another important step. While the app is in testing mode, only the test users you list here will be able to connect to Google Calendar. So you'll need to add your own Gmail account here if you want to do the testing. The final step is to create the OAuth credentials that let cal.com talk to Google securely. What you want to do is head over to the overview and then select create OAuth client. Choose the application type as web application. Choose a name for it. And what we want to do is add in authorized redirect URIs by selecting the add URI. What we want to do is add in these three authorized redirect URI. Port number would need to match what you currently have set up. These are just return addresses. They tell Google where to send users back after a login. If you miss one, you'll hit errors later on when connecting to calendars. Once you've added them in, select create. And what you want to do is make sure to download the JSON. You only get one chance to download it, and if you lose it, you'll need to rotate and create a new one. We then want to add the OAuth credentials to our .env file. Copy the credentials from the downloaded JSON file. Inside your .env file, find the Google API section and paste your values. Since the .env has changed, restart your container so Docker picks up the new values. The command that you can use is docker compose down. To start it back up again, we need to run the docker compose up/d. That should reload our settings and make sure cal.com now knows about the new Google APIs. Now, to test and connect Google Calendar to cal.com, we'll head over to localhost port 3000, fill in the basic details, and then select next step. And in this section, we want to select the connect option. We should now see Google asking you to select an account. We want to select the first option here. We then want to select continue and then continue again here. And then we want to select this option that says select all and then select continue. Cal.com should now redirect you to another page asking you to connect your calendar. We want to ensure this is enabled and select continue. In this section, it's asking us to connect to a video app. What we want to choose is the Google Meet option. So select connect. And now you should see that Google Meet has been installed and it's set to default. We then select next step. Here you have the option to define the ranges of time that you are available. We want to keep the defaults and select next. You then got the option to add in a profile photo and a short description about yourself. And once you've selected finish, you should see the events type section. Now that cal.com is connected to our Google Calendar, let's go ahead and schedule an appointment. This is the point where you decide what kind of events people can book with you, how long they last, and how they appear in your calendar. Since my focus is on the clinical use cases, I'll be showing you an example like new patient consultations and follow-up appointments. But the process is exactly the same no matter what kind of service you're offering. In the event types tab, you can see a list of events that you have, and once you have a booking, they will be shown under the bookings tab. Now let's go ahead and create a new event. We then want to choose a title and a short description. I've put down introductory consultation here, and this would pre-fill the URL for you depending on the title name, and we would need this bit later on. And then you select your duration and then select continue. On the event setup page, most of the details have been passed over, so we don't need to make any changes here. Here you have the option to enable this setting, and this would allow the user to select the duration time. For the location option, we want to choose Google Meet. That way, every time someone books an appointment, cal.com will create a calendar invite and attach a Google Meet link automatically. We also have the option to add another location. And if you can't find the one you're looking for, you have the option to visit the App Store to install it. Next, we have the availability. By default, cal.com can read our free and busy times from Google Calendar, but we can also restrict the specific event types to only certain certain hours. For example, maybe consultations are only available Tuesday and Thursday mornings. This is a great way to make sure patients only see the times that you're actually available. You can also update these times down below here. On the limits tab, here we can set things like minimum notice time. For example, patients must book at least 2 hours in advance. Buffer times, where we can add minute gaps between appointments so we don't run back-to-back meetings. And a few other settings such as limiting how many consultations we can take per day. These small settings prevent overbooking and keep the schedule manageable. In the Advanced tab, this is where we can fine-tune how our bookings connect to our calendar and how conflicts are handled. At the top, you'll see the Add to Calendar option. This is the calendar where new bookings will actually be saved. Because we connected Google earlier, I can pick my Gmail calendar here. You can also choose to show your calendar email as the organizer, so patients see it on their invites. Next, on the Check for Conflicts, this tells cal.com which calendars to look at before confirming a booking. For example, I'll leave my main Google Calendar toggled on so I don't get double booked, but I could also include any holidays or any shared team calendars. Finally, there's a layout section. This just controls how the booking calendar looks to patients, whether it shows month view, week view, or a simple list. We then have the booking questions section. We can toggle on the options or the questions we would like to show up on the cal.com. In my example, I've got the email address, the additional note, add guest, and reason for reschedule. Some of these are optional, but some are required, like these two. As you scroll further down, there are even more options like custom booking questions, confirmations, and restrictions. You don't have to touch all of them right now, but it's good to know that you've got a few options, and depending on which ones you prefer, you can enable them. Once we've completed filling out these settings, we can hit the Save option at the top here. We can then preview the booking page by selecting this Preview option. This is what the patient would see, a simple calendar interface where they can pick a time slot that works for them. In this example, on the 27th, we've booked out from 10 a.m. till 4 p.m. And on the interface, we can see that those time slots are not available. What this means is that you can book any time slot that you are not available. And this would enforce the user or the client to only select the times that they can see on the interface. They can then go ahead and select a time slot and put in any additional note. You can see here that we've got the add guest option as we've enabled that on our settings. We can also see that Google Meet has been linked as a video call option. On the top, we can see the Google account, that is the host, the title and the short description, and the appointment time. Once they select confirm, they'll be redirected to this booking confirmation page, and it shows who the host is, the user or the client email, where the meeting would happen, which we've set it as Google Meet, and what the meeting is about. A confirmation email would also be sent to the user or the client with a Google Meet link. Down below here, they've got the option to reschedule or cancel the appointment. That's really the power of cal.com. You get both a ready-to-use scheduling system and the flexibility to integrate it anywhere. I quickly want to talk about the webhooks tab and how I've set it up for my example. The reason why I added a webhook is so that whenever a booking is created on cal.com, the booking created event would send the details to my backend system via this API endpoint over here. This is one way I've integrated cal.com to my platform, as both are two separate applications, and I would need the details from cal.com to be passed over to my application. At a high level, there's an API endpoint in my Django that receives the booking ID, the booking start time, as well as the email. Once those details are extracted, it would be stored in my database. This is completely optional, and there might be other ways to integrate it, but it's how you can connect cal.com to any workflow. Another powerful feature is embedding cal.com into your own application. In my setup, I've connected to my patient intake form. You can select this embed option over here and select one of these options to choose how you want to add cal.com to your site. In my example, when a patient submits the intake form, they're taken straight to my cal.com booking page using the data from the intake form. So even though it technically redirects to cal.com hosted link, from the patient's perspective, it would feel like it's fully embedded into the application. This way, cal.com still handles all the booking logic while my app controls the intake flow. So that wraps up our walkthrough of cal.com. The big benefit of using cal.com is that it gives you a professional automated scheduling system without the endless back and forth emails. Once it's connected to your calendar, patients or clients can only book times that you're actually available, and every booking automatically creates a calendar event with all the details. On top of that, it's flexible. You can set clinical event types, add rules like buffer times or booking limits, and even extend it with webhooks or embed it into your own app. Whether you're running a clinic, managing client meetings, or just trying to organize your own availability, it adapts to your workflow. If you found this video helpful, please give it a thumbs up and subscribe. In the next video, we'll build up on this and look at how to take cal.com bookings even further with integrations. Thanks for watching.